Hello, I'm James Bailey from Transmille. We're going to go through a few tutorials on making some good connections, covering some groundwork that maybe metrologists should be aware of. The first one that catches a few people out is the thermoelectric voltage is generated when two dissimilar metals come into contact with each other. This effect, of course, is used in thermocouples, which are simply two wires of different materials twisted together at the end. Very easily can produce voltages in excess of 40 microvolts per degree C. Now you might say, well, no, I don't use connections in my leads, I just take a 4mm banana plug and one end to the other end. But of course it's the plug itself, the banana plug, into the socket that it's going into, that is an electrical connection where two dissimilar metals come into contact with each other. And we're just going to give you some ideas to get a feeling of kind of the voltages we're talking about and how significant they are when we're making measurements of 10 volts or 1 volt, even more, yet alone 100 millivolts. I have here a null meter. It's set on the 30 microvolt range, so it's quite an insensitive range, and at the moment I've just got two short leads in it with a couple of copper connectors, gold-plated copper connectors coming together, and you can probably see if I deliberately introduce a bit of temperature into the junction between the two, you really get very little difference on the null meter. But if I introduce a good old steel crock clip into the equation, just breaking the line for a minute and introducing a crock clip, here we are, we can see without even touching it, we've got sort of 10 microvolts or so. And if I put my little hand on there, it's going way off over 30 microvolts. So that's just a humble crock clip inserted in the line. So taking another example, using the traditional brass, nickel-plated brass banana plug. Very common everywhere. Again, huge voltages. You know, we're talking here, well, you can see it, 10 microvolts at least there. Just that. So that's another little problem. If we use one of the typical kind of silver-plated connections on a typical test probe, and I go in here, again just making a short, again you can see 15-20 microvolts of voltage. Now if this was at the 1 volt level, that would be representing 20 to 30 ppm worth of error, just because you've used the wrong test leads. So when you see test leads like this, that have usually a silvery finish on them, could be tin isn't actually too bad, could be nickel of course is disaster, or chrome, to make the ends nice and shiny so they look good in the shop, but they're really not much good for making a precision measurement. Going to the other end of the quality scale, and these are from a company called Pomona, the copper gold-plated spades are the best. So there we have a few quick measurements giving you a feel for the kind of errors you will get when you're connecting up using different materials. The other thing, of course, you need to remember is it's not just your lead that's going to be important, it's what it's going into that will be important too. Now, all of the precision manufacturers, their instruments will have on them low thermal, usually copper or deoxygenated copper connections, which are almost always gold plated. So whether you're looking at a precision calibrator or a precision multimeter, the terminals here will be good quality copper gold plated. Whereas of course the humble test lead that you'll probably pick up from your bench will be some kind of nickel, maybe if you're lucky silver plated brass, because obviously that is a much cheaper and more hard wearing connector than the softer copper, gold plated coppers that are being used on the instruments. It's important that they should match. It's when you get dissimilar metals together, you get the high thermal voltages, which will lead to errors of many tens of ppm when you're working at the 1 volt level, and when you're working at the 100 millivolts level, you're talking hundreds of ppm of error.